Hi everyone, today we're going to talk about basic geometric constructions. Geometric constructions are putting drawings together and putting objects together. It's the way things fit in a 2D world. So we've got a quick PowerPoint that I want to go over. So if we go to our next slide here. So geometry is basically just the study of the size and shape of things. It's what we've got, how straight lines and curves fit together more than anything else. You've got to realize that geometry, no matter what, we've got to have it to create solid models, okay? So, and to create multi-views or whatever the case may be. A solid model is a 3D image. A multi-view is looking at it from different sides. So our first thing to look at in geometric constructions, it's real easy. We're just going to start with two sides. So we're going to talk about angles. And of course, we all know that an acute angle measures less than 90 degrees. If you think acute angle, so it's cute, so it's small, so it's less than 90 degrees. Obtuse angle, think obese, means it's large. It measures greater than 90 degrees. We all know what a right angle is from math class and everything. It measures exactly 90 degrees, one angle does. And then the vertex, if you look down here, the vertex is anywhere you have two lines forming a corner. Okay, so that's your vertex. All right. Our circle. For a circle, we've got some things that we need to know real quick about it, and it's pretty straightforward and simple. So you know that the diameter is all the way across. Now, the thing about it is we want to make sure we know our definitions. And I'll jump down. I'll go back to radius. Our diameter is all the way across the circle, touching it in 2 points, but it crosses through the center point. That's important, okay? The radius starts at the center and goes to the edge. So it's half the diameter, obviously enough. A chord. A chord is a line that touches the circle in 2 points, but it does not cross through the center point. And circumference, of course, means the distance all the way around the outside of the circle. All tangent means is that it touches the circle on the outside or the inside at 1 point. Now notice, tangent, it touches 1 point and 1 point only. So this line, when it passes down through here, it touches one time right there. Okay? More things about a circle. Now, of course, we know that a circle has 360 degrees. So if we start to the right, 0, 90, 180, 270, and back to here would be 360 back when we come around here. So what if we divide that into 4 equal parts, so like our north, south, east, and west, this would be called a quadrant because of 4 sides. Quad meaning 4. So see here in this picture. So a circle has 4 sides, 4 parts equal in a quadrant. If we have 2 circles or an arc in a circle that share the same center point, like these two do, they're called concentric. Okay? So you can have concentric circles. These are concentric ellipses. So let's move on to 3-sided figures. So triangles, of course. Triangles. An equilateral triangle. All sides and all angles are equal. If all angles are equal, remember all triangles have to add up to 180 degrees. So if it's an equilateral, every angle will be 60 degrees because 3 times 60 equals 180. An isosceles triangle, 2 sides and 2 angles are equal. A scalene, no sides and no angles are equal. And here's some in color that we can look at. So how about a right triangle? Well, a right triangle means that one of the angles out of 3 is a 90-degree angle. The hypotenuse is the side opposite of the 90-degree angle, and it will be the longest side, okay? And again, remember, our vertex are where the lines come together and form the corners or the angles. Quadrilaterals, 4-sided figures. The one everybody knows right off the bat, of course, is a square. For it to be a square, all sides have to be equal and all angles have to be 90 degrees. For a rectangle, opposite sides only are equal. All angles are still 90 degrees, but opposite sides only. Now, I know some people will say that a square can be a rectangle. If we include the word only in there, it cannot. A square has all sides equal. A rectangle only has opposite sides equal. So just sort of remember that. Now your math teacher will tell you that a square can be a rectangle. When you're in math class, that's okay. But when you're in engineering, we need to go about it this way. Trapezoid. So a trapezoid only has two sides that are equal length. So it's these two, the two that's leaning. Okay, and only two sides are parallel. That's these two. Okay, so that's the reason why we get the look that we get here. Our last two are two kind of odd looking ones, and a lot of people want to call these parallelograms. Well, that is an overall general term for them, but we've got exact names for them. If you look at this one, it's called a rhombus. All sides are equal. Okay, so all these are the same length. And opposite angles. This one and this one, this one and this one are equal. Think of it like a square that you leaned on and sort of pushed it over a little bit. That's what you'd end up getting. These two angles here will be obtuse. These two angles will be acute. Okay. What if we did the very same thing to a rectangle? Then we're going to get a rhomboid. So opposite sides are equal and opposite angles are equal. Same thing. These two are acute. These two are obtuse. Okay. So you leaned against a rectangle and pushed it over a little bit. That's what you get. What's a polygon? Well, a polygon is a multi-sided figure. So once we, a three-sided polygon would be an equilateral triangle. A four-sided polygon would be a square. Okay, but then we start grouping them all together after that, and we start calling them regular polygons after that. Remember, for it to be regular, all sides and all angles must be equal. So like it says there at the top, like an equilateral triangle or a square. We sort of need to know the names of them. And here's the three that we're going to use the most. A pentagon is a five-sided. Okay? If you do this perfect, we could draw a five-pointed star inside of this, a perfect five-pointed star. Okay? The degrees on these, if we took 360 and divided it by 5. Okay? So let's divide it by 5. So 300 divided by 5 would be 60. We've still got 60 left over. 60 divided by 5 is 12. So 60 plus 12 is 72. So every one of these angles are 72 degrees. A hexagon. Hexagon's six-sided, of course. Okay? Every one of the angles here, 360 divided by 6, would be 60 degrees. Okay? An octagon. Here's our stop sign. 8-sided. So the degrees between each one of these is 45 degrees. Okay, so we need to know these three no matter what. Our other ones, we need to know the names of them, but we won't use these much. So a 7-sided figure, just according if you want to do Greek or if you want to do Latin. So if we do Greek, it's called a heptagon. If we do Latin, it's called a septagon. Okay, 7-sided figure. We've already done 6 and 8. A 9-sided figure is called a nonagon. 10 is a decagon. I'm going to skip down. 12 is a dodecagon. Deca meaning 10, do meaning 2. Dodecagon. Okay? One with 11 sides. The general term that you're going to hear used is an 11agon, but there is actually a name, and there's two of them. You can call it a hendecagon or an undecagon. Un, means one. So that's something you can throw at your mom or dad or somebody, and they may not know this. This will be something that you can sound really smart if you use that. It'd be kind of cool. Okay? So how do we draw these, though? They're regular polygons. Well, this is one of the times that we're not going to start with a square to draw something. We're going to start with a circle. So let's look at the next slide. When we draw regular polygons, we can draw a polygon outside of a circle or inside of a circle. If we draw it outside of the circle, notice that if we measure from here across, so let's go from here to here, okay? From here to here, we measure it across. Look what we've got. We've got across flats, okay? Because it touches the flat part of the line, okay? Or the middle of the line. So on the outside, it's across flats, okay? So the other name for that, if it's drawn on the outside, is circumscribed. Circum meaning outside the circle, around the circle, circum, like circumference. Scribe meaning to draw. Okay? Well, if we draw it inside, and by the way, if you didn't notice, 1, 2, 3, 4, 5, 6, 7, these are septagons inside of these circles and outside. If we draw inside, notice here now the corners are touching the circle on the inside. So this is across corners, and it's called inscribed because we drew it inside the circle. So you need to know the terms for a regular polygon. If it's drawn inside the circle, it's called inscribed, and it's measured across corners because you're going to see these two phrases. If it's drawn outside the circle, it's going to be called circumscribed, and it's going to be measured across the flats, the flat part. Okay? So those are some terms you really need to know. So let's go look at some more here. And here's some really good pictures. So circumscribe again. So we start with a circle. And notice these are just two basics. Yes, you can do a equilateral triangle and a square using the circumscribe method. Here is a hexagon. Again, notice that this way, if we crossed right through the center with a line, it would go from the midpoint of that line to the midpoint of that line and cross through the center point. Same thing on our octagon. Okay? We could go straight between them. And here to here, it would be perpendicular to this line. Same thing here. If we went from here to here and drew a line, they would be perpendicular to these, 90 degrees. Okay? Inscribed, and they start with a square and a circle. Here's our pentagon, our hexagon. We get to here, look what we've got. Oh, there's our septagon, okay, or heptagon, whatever you want to call it. Here's our octagon, our nonagon, and our our decagon. So that's how we're going to be drawing those. Well, what if we wanted to make these 3D shapes? Well, if we took a triangle and added depth to it, see that center triangle right there? We've got what's called a triangular prism. You'll see these a lot of times in science fairs. People will shine light into it, and it'll come out the other side and look like the rainbow. It's called refracting light. What if we take a rectangle or a square and add depth to it? Well, if it's a square, you know, it's going to be a cube if we make it the same height as it is wide and deep. If it's a rectangle, then when we add our third dimension, it's called a rectangular prism. Okay? Our other solids, take a circle and add height to it. Hey, it's a cylinder. It looks like a can that a soda would come in. How about if we take a circle and bring it up to a point? Now we've got a cone, like an ice cream cone. And if we take a circle and spin it around on its axis, so if we put an axis right down through the middle and spin it around on its axis, now we've got a sphere. Well, let's think about the Egyptians. Look here. How about a pyramid? Now, this is interesting because this pyramid could be one of two things. We can't see the back edge of this. We can see that we've got sides and it's coming to a point, but how many sides are there? Are there 1, 2, 3? Or are there 4? Because if we had a dashed line across here to represent a hidden line that went all the way across there would only be 3 sides. So that would be a triangular base pyramid. If we had 4 lines, so another line going here and another line going here at the bottom, now we would have a square-based pyramid. Okay? Here's one of my favorite ones. I know it looks like a donut. I get it. I understand. It just needs glaze on it in a Krispy Kreme box, right? But the proper name for this is called a torus. Okay, T-O-R-U-S. A little strange sounding name, but a donut shape is a torus. So we talked about that we're going to be doing geometric constructions. Well, geometric terms that you need to kind of know. And I know these down here are a little hard to see, but bisect means to divide a line or an arc into equal parts. So here's my line, and here's where I divide it. Okay? Tangent means something's going to touch something in one place and one place only, either a line and an arc or 2 arcs. So look, this arc touches this line in one point and touches this line in one point only. Okay? We can do the same thing with arcs. Like I said, these are kind of small c, but here's an arc, and here's an arc, and there's an arc between them. Okay, same thing here. Here's an arc, and here's an arc, and here's a little arc between them. Okay? Parallel, 2 lines that will always stay the same distance apart no matter how long they are. Okay? Perpendicular, we've already talked about that. Perpendicular means that they touch each other or cross at 90 degrees. Okay? I'm going to go back one slide and tell you something on this. On the tangent, we're going to be using this a lot, and we've got a circle command that will allow us in AutoCAD. It's called tan radius. And what that means is we can do tangent to 2 lines and then give its radius, and it'll draw that for you. We can draw lines tangent to a circle or an arc just by typing in, once we get into the line command, by typing in tan and hitting enter and then touching what you want it to be tangent to, and it'll draw it tangent to it. So it's really kind of neat. Okay. Perpendiculars, we use these a lot to find tangent points too. Perpendiculars will come into play. You'll see on the next video. So geometric symbols we need to know. You already know this one. There's the symbol for diameter. Okay, a line, a circle with a slash through it. It kind of looks like the Greek letter phi, and that is pronounced phi, even though it's phi. Okay. Radius is just the capital letter R. This is the symbol for angle. Look, it looks just like it. Triangle looks like a triangle. Square looks like a square. Parallel are two lines like that. Perpendicular, it's not showing up on the screen like I want it to. It should be an upside down T is what a perpendicular looks like. And if you ever see this, a C and an L interlocked, it means center line. Okay? So there comes perpendicular. Look, it popped in at the very end. So we've got it. Okay, so that's a quick rundown on geometric terms that you're going to need to know. We'll go over some more once we get into the drawings. Have a great day.